Okay, so now it's time to actually measure stuff, right? So if I go in my touches began here, I'm going to check if we are adding point A or point B. So first we need to check that. So outside of this function, I'm going to call a variable, that create a variable that's going to track this. So it's just going to be is first point, and that's going to be set to true, obviously, because the first time is going to be the first point. And in here, come on, Xcode. Okay, so in here, I'm going to then check. So if is first point, then I do something, and if it's not, I do something else. Okay, so first of all, obviously, we are going to need to change this. So is first point here is going to now be false, and here is going to be back to true. Okay, now in here, so if it is the first point, then we just add the point, and that's what we've done here, so everything's okay. If it's the second point though, then we need to do a few things. First, we need to, well, calculate the distance. Then we need to add a line. We'll also add a midpoint. And finally, we will also add some text for the measurement, okay? And finally, we'll actually have a little surprise here. So, surprise. Okay, so first of all, let's calculate the distance between point A and point B. Now, we don't actually have a reference to those here, so what I need to do is to record all my points. So in here, I'm going to create a variable that's going to save all my points, and that's going to be an array of SCN node. That's going to be empty at first, and in here, when we add the child node for our sphere, we are going to also add a point here in this array. So points dot append, and the new element is obviously our sphere node. Okay, so here we said calculate this distance. And to calculate a distance between 2 points, well, you first need 2 points. So let point A equals, so point A would not be the last one in our array here, it would be the previous one. So what I'm going to do is go for points, and I'm going to get points.count minus 2. Yeah, because obviously, so points.count, so the array starts at 0, but the count obviously starts at 1. So in here, I'm going to do minus 2 and let point B equals points. So I could do the same construct and just minus 1 really, but what we really are interested in is the last point of our array. We can make sure that these exist, so guard let, and I'm just going to add a comma here, so let point A points blah blah blah, and point B points last. Okay, so else, oops, else return. Okay, so does this work? It does not, because point A should be optional. Right, so there's a problem here. So count minus 2. So our point A will always exist. Let's just do this, and then we just guard for our point B. How about that Xcode? Let's just check. Yep, seems to be happier. Excellent. So we have point A and point B. So we can now calculate the distance. Let distance equals. And in here, well, it's actually very simple. We just call distance like this. And you see we have quite a few that we can use. And if you look at this one, so x and y, we have a float 3 and a float 3. So that's good. That's almost what we've got. We've got SCN vector 3 instead of float 3. But the good news is that we can actually cast one into the other. So in here I get my point A, and in here I get my point B. And this, actually, it's the position of them. So position and position. Okay, so Xcode should not be happy about this. Yeah, build failed because yeah, it doesn't understand really what's going on here. So the distance, oh, I can't call distance into distance. So let D equals distance, and then yeah, it doesn't work with vector 3. What we need is float 3. So what I can do is just take all of that and make this a float 3. And you can make a float 3 from an SCN vector 3. Very easy. And in here, same thing, float 3. Excellent. So now we do get our distance. And what we can do is to create a line between those 2 points. And this line is going to be a geometry that we are going to have to create ourselves. You may have noticed that lines actually don't exist. I wish we had SCN line, but it doesn't exist. So what we need to do is to create a little extension. So if I go right at the bottom here and make a little bit more space, I can make an extension for SCN geometry. SCN geometry. Okay. And in here, well, in here we want to basically get a function that's going to return a line from vector 1 and vector 2. So from vector A, which is an SCN vector 3, to vector B, which is also an SCN vector 3. And this is going to return an SCN geometry. Okay. Then, so in here, what we need to create our own geometry is indices and, well, sources and elements. So if I want to create a new geometry, let's geo, so yeah, let's just say line geometry equals, so that's going to be an SCN geometry. And in here you see that we can create our geometry from sources and elements. And that's what we are going to need here. So geometry source is going to be our vertices, so the points vector A and vector B. So I can say let source equals SCN geometry source, which is going to take our vertices. So let me just source and that one. So from two vertices here, I can pass an array with vector A and vector B. Okay, so here we go, and now in our source here, I'm just going to add source. Good. And for elements, well, this is basically all the different elements that we have, or the element that we want to create. So the element we want to create is a line, and let's just create it here. So element equals, and that's an SCN geometry element. I see it's got one here, and this will need indices and primitive type. So for the primitive type, this is where we have a dot line. There you go. So that line, and in here, so fixed width integer. So this is where we are going to need to put our indices, really. So here I'm going to put indices like this, indices, and I'm going to call to create my indices, which is an array of int32, and it's going to be equal to 0, index 1, I guess, and 1. So we have 2 points, vector A and vector B for our sources. Then we have an element, so the SCN geometry element, which is taking our indices, and it's got a primitive type of line. And here finally we've got our line geometry, which takes the source and the elements. So in here I just have to call my element like so. Okay, and we're just going to well, we can pretty much just return this straight away. Okay, so there you go. This is a cool little extension that obviously you are more than welcome to copy and paste and keep it safe somewhere in your code, because this is going to be very useful for you to reuse one day, I'm sure. Now let's go back to where we were here, and now we can add a line. So if I want to add my line now, it's going to be much easier, because I can just create my line equals SCN geometry, and in here, oops, geometry, and then I can call my line it should work. Why is this not working? Where am I? So yeah, here, line, and there it doesn't work. What have I forgotten? Does this need to be a class func? I think it does. Right, so let's try again. Line. Yeah, okay, so this is now working. So we have a line from vector 3 to vector 3. Excellent. So that's going to be my point A dot position and point B dot position. Good. Okay, so we can also maybe print our distance, and I think this is this is going to be okay for distance does not exist. It's d that we've got here. Okay, so d dot description, so that's going to be in meters, don't forget. So if I add my first point, let's make sure we're not too blurry here. Okay, so from here to there, I forgot to actually add the line to the scene view. However, if you look into the console, we can see that we've got our 18 centimeter here. So this is working. Let's just add our lines. So if I call the scene view, let's scene.rootNode.add child node, and this is obviously going to be my line. However, this is a geometry, so let line node equals scn node, and here I'm going to pass the geometry, so that's going to be my line. Add child node, so yeah, line node. Let's run. So if I start moving, I can add a point here and a point there, and you can see now that we have our line in between our 2 points. Excellent, and this is 37.8 centimeters. So the next video, we are going to finish up this project. We are going to add the middle point, some text, and the little surprise also.